we have 2 kilograms over here, we have 10 kilograms over here, and there's a wall this way, and we have to apply a force in this direction. Okay, and friction coefficients are also given to us. The friction over here is mu equals 0.1, and friction here, this point, is mu equals 0.15, and these are static coefficients, and that makes sense because we want the whole system to remain stationary. Okay, what's the logic we're going to use? First of all, why don't they fall down? What's countering gravitational force? It must be frictional force, right? The gravitational force must be countered by the frictional force. In fact, you know what? What's the first thing we can do? We can calculate what the frictional force is supposed to be. Think about it. If we go to 2 kilograms, we know for sure there's a 20 Newton force acting this way. The only person who can counter that is frictional force. So friction has to be 20 newtons. It has absolutely no other choice. It can't be more than 20 newtons, it can't be less than 20 newtons, it has to be exactly 20 newtons. Okay, also, and then there's a force over here, that force is F, and that force is countered by the normal force, the 10 kilogram is going to put on this guy. So that's going to be normal force. I'm just going to call this as N1. These are the forces acting on 2 kilogram object. Let's look at the forces acting on 10 kilogram object. There is 100 Newton force acting downwards. There is what? There is a frictional force due to this guy downwards. Notice, because 10 kilogram put a force upwards on 20 newtons, this guy's gonna put a force downwards on, so I'm gonna use red for that. So there's a 20 Newton force acting downwards. Similarly, there's a normal force. This guy's gonna push this way, normal force, and the normal force will be N1 itself. The wall is gonna push this way, and that is gonna be N2. And we have frictional force. Notice, for this to remain stationary, frictional force must be 120 newtons. Oh, you know what? We already calculated part 2. We already know what the frictional forces are. Now all that remains for us is to calculate what the minimum force has to be. Well, let's see. If the force decreases, notice that F equals N1. Can you notice that? F should be equal to N1. And also notice N1 should be equal to N2. Alright. Now we know that if force decreases, N1 will also decrease. And if N1 decreases, the maximum frictional force here and the maximum frictional force over here starts decreasing. So the minimum force we need to apply is when one of these frictions become maximum. So let's see, when does this friction become maximum? I'll call this as F1 max. If we call this as 20 Newton, then this friction becomes maximum when you have normal force as friction is mu s times n equal to 20. So normal force, or N1 I should say, normal force N1 is 200 newtons. What we have calculated is that if the applied force is 200 newtons, that's when the friction gets maxed out. See, applied force is 200 newtons, then the friction gets maxed out. If your applied force is less than 200 newtons, then the friction will not be able to handle this guy. It's gonna just fall down. So that makes sense, right? So we know that the frictional force has to be at least, the applied force has to be at least 200 newtons. But we don't know if it's enough because it has to handle this guy also. So let's see what's going to happen when friction is maxed out in this case. If friction 2 is maxed out at 120, then the required normal force to max it out is going to be this mu s, that's 0.15, into normal force, that's N2 now, is equal to 120. So N2 is 120 divided by 0.15. I have to do some math here. So let's see, 524 times, it's 0.3 times. So that is 80 newtons. That's all I need. I hope I haven't made any mathematical errors. It's 24.3, 240 by 3. That's right, 80 newtons. So what we see now is, in order to max this guy out, we need a minimum of 80 newtons. So either we need minimum 80 or we need minimum 200. So the answer is obvious. The required minimum force is 200 newtons. So F min is 200 newtons.